Okay, in this video we're going to have a look at normal distribution. We're going to look at some samples and decide if they're normal. The first thing that we need to be able to do this is actually look at what are the features of a normally distributed variable. What does it look like? So let's have a look at that. Right, there are 4 features of a normally distributed variable. The distribution curve for a normal distributed variable. The first is that it's symmetrical. So if we draw a graph of it, and this is an area graph I've done, it's symmetrical. We would expect that it's going to look roughly the same on the left as it does on the right, because a perfectly normal, standard normal is symmetrical. Next one is that it's unimodal. That means it has one peak. One peak or one mode. Now you'll probably remember mode as the least useful statistics from year 9. Turns out mode's really useful when you're talking about groups, because it's the easiest one to see on the graph. So that's what it's got, one mode. Alright. Oh, it's going to move that with my picture. Okay. The mean and the median are the same. Right, that's another important one, that our mean and our median are the same. Right, it's one of the features of a normal distribution that we have the mean and the median that are the same. Right. The next one that we have is that 90% of the data is within 2 standard deviations, 95% of the data is within 2 standard deviations, and 99%, let's try and get that to work, are within 3 standard deviations. So if we look here, we can see that on here we've got the standard deviation lines. But a lot more clearly is if I look at this one here, which I've taken a histogram that's got slightly bumpy. But here we see the pink, the yellow is within 1 standard deviation, the grey is within 2 standard deviations, or between 1 and 2 standard deviations. The brown is within 3 standard deviations, so between 2 and 3, and then the blue on the outside is more than 3 standard deviations. And you see hardly anything is more than 3 standard deviations away. Not very much is more than 2, and almost all of it, or a large proportion of it, is within 1 standard deviation. That's one of the ways that we can tell that something is normally distributed. Okay, here's a little set of videos where I'm looking at changing the sample size and what that has on a normally distributed random variable. Have a look at this one here. Okay. So here is a dot plot showing a normally distributed variable. This comes from a perfectly normally distributed population, and it's a sample of 30. And you'll see each time I do it that our sample actually gets quite different. And it looks quite different each time. And you can't look at this one and say it's symmetrical. You can't look at it and say the mean and the median's the same, or, I mean, this one's unimodal, but they're not all unimodal. And the mode is certainly not at the mean or the median. Here's a bimodal one. We can't say much about it when we've got a normally distributed variable with a really small sample size. You see, each time we do it, we're going to get a different. And so one of the things we have to be careful of is saying, oh, look at this feature and say, therefore this is not normal. Right? With a small sample, we can't tell much. It might be normal, it might not be. And if we get a sample like that, a lot of people would look at that and say, oh, it's not normal, because look, it's not symmetrical. It's got a peak over at the left of 10. It's skewed. There's no, it's bimodal. It's just not all over the place. But it's such a small sample you can't really tell. Okay, this time we look at a normally distributed variable with a sample size of 100. So we've got a larger sample, and again, every time we take the sample, it's going to be different. Now these are starting to look a little bit better. We're looking at them, they're having it's a little bit more unimodal. It's starting to get that normal shape, but it's still not perfect. And one of the things that we have to be careful of is not to jump and say, oh, look, it's not perfect, therefore it's not normal, right? We're looking for something that normal is a reasonable model for. And while it's not perfect, that's a reasonable model here with a sample size of 100. All right, now we've got a sample size of 300. It's still not perfect, but it's starting to get a lot more consistent. But again, we've still got, every time we take it, we have to remember we have sampling variability. So every time we take a sample, it's not going to be not going to look like a perfect normal distribution curve. It's going to look slightly out, and we have to expect that. So it would be very tempting to look at this one here and say a triangular would be the best. But as we start taking more samples, we see that there is a natural variation that happens with normally distributed samples. Right? For this one here, the mean is supposed to be 20. But if you look, it's very rare that the highest point's actually at 20. It is for that one. It's not for that one. It's not for that one. It is for that one. It's not for that one. It is for that one. So you see it moves around. 19 this time. 20 this time. 19. 20. It's going to change each time. Right? Here we've got 17. So we can't expect it to be perfect. But once we get to 300, it starts looking pretty good. Alright, now we look at a sample size of 1,000. And we're starting to get that, the normal thing's starting to get a lot more pronounced. We're starting to see that. But again, if you look at it, it's not perfect. There's fluctuations in it. So there's always a chance when you look at one of a normally distributed sample that it's not going to be absolutely perfect. And even with a sample size of 1,000, which is a pretty big sample, there's still quite a bit of variation. So we have to keep that in mind, that while we can get a pretty good idea about the mean from a small sample, we can't really tell much about the distribution until we get quite large samples. So what you see here is that as the sample size increases, it starts looking more and more normal, more and more like what we would expect it to look like. But there is always a degree of variation. We have to be careful to not look at that variation and say, oh, therefore it's not normal. Okay, final thing here is your question for today. There's 3 random variables, x, y, and z. I want you to decide if any of these are normally distributed or if normal distribution would be a useful model to use with any of these. Right, we'll have a chat about it in class tomorrow. Please make a comment on the video saying that you've watched it. That'd be great. Thank you.